Hi, my name is Evelyn Mesler, and I will be working on problem 39 from Kinetics, Chapter 14, on page 665 of your textbook. The question reads, a reaction in which A, B, and C react to form products is first order in A, second order in B, and zero order in C. A. Write the rate law for the reaction. A rate law is the relationship between the rate of reaction and concentration of reactants. While the concentration of reactants isn't given here, they do give you the rate of reaction. A is first order reaction, B is second order reaction, and C is zeroth order reaction. You can take these orders and raise them as exponents to the concentrations in your rate law. So here we have K, your constant, times A to the first order, B times the second order, C to the zeroth order. B, what is the overall order of the reaction? The overall order of any reaction is the sum of the exponents in the rate law equation. So here you take your exponents from part A, 1, 2, and 0, add them up, you get 3. That's your overall order. C. By what factor does the reaction change if A is doubled and the other reactant concentrations are held constant? So you take your original rate law from part A and you write a modified rate law to compare it to. The only thing I did to the modified rate law is substitute 2A in for my original A because the concentration of A is doubled. So doubling the concentration is equal to 2A. When comparing these, you can distribute the factor of 1 to both 2 and to A. So 2 to the first power is 2. So you can pull that in front of your equation. So it would be equal to 2K. And then A to the first power is A. So 2K, A to the first power, B to the second power, C to the zeroth power. If you look at them carefully, the only thing that's different between the first equation here and the second equation, 2k a to the first, b to the second, c to the zeroth, is the factor of 2. Therefore, 2 is the factor that the reaction changes by. D. By what factor does the reaction change if B is doubled and the other reactant concentrations are held constant? This is very similar to part C. You compare your original rate law to your new rate law. The only thing I did in my new rate law is substitute 2B in because the concentration of B is doubled for my original B. In comparing them, you can distribute the power of 2 to both 2 and b, giving you 4b squared. And then you can put that in your modified equation. So my new equation is 4k a to the first, b squared, c to the 0. And my old equation is ka b squared, c to the 0. Meaning that the only thing different between the original rate law and the new rate law is the factor of 4. Therefore, it changes by a factor of 4. E. By what factor does the reaction change if the concentration of C is doubled and the other reactant concentrations are held constant? Your original rate law, again, is from part A, and you compare it to a new rate law where you substitute 2C in because the concentration of C is doubled for your original C. It's important here to know that anything to the 0th power is equal to 1. So no matter whether it's C to the 0th power or 2C to the 0th power, you're basically multiplying K, concentration of A, concentration of B squared by 1 in both equations. Therefore, both equations are the same, and you're multiplying it by a factor of 1. The reaction rate does not change. Finally, F. By what factor does the reaction rate change if the concentrations of all reactants are doubled? So you would do what you've been doing in C, D, and E. You take your original law, which is your rate from part A, and you compare it to a new law where you substitute 2A, because the concentration of A is doubled, 2B, and 2C. In the same way you have in part C, D, and E, you distribute. So you distribute 2 to the first power is equal to 2. A to the first power is A to the first power. 2 to the second power is equal to 4, seen here. 2 to the 0th power and c to the 0th power is equal to 1, so you can just cross that out. So 4 times 2 is 8, so it's 8k, or 8 times your original equation. See, ka1b2, ka1b2 times 8. Therefore, your answer is 8. Your factor increases by.